In this quick video, we'll learn about the average rate of change over an interval. So this is the formula for average rate of change of a function f of x on the interval from a to b. A and b are the x values that we are finding the average rate of change over that interval. So as you can see, rate of change is really just slope. It's another way of finding the slope basically between 2 points on a function, because this is the y value when the x value is b, and this is the y value when the x value is a. So we're doing y minus y over x minus x, except it's just called a and b here because we're traveling over an interval. So let's do a visual example here. Here is our function f of x, and we'll call this point a f of a, and this point b f of b. And so we can see, even though I've called them a f of a, right, input, the x value, and then its corresponding output, its y value, we could also call this point 0, comma, negative 7, and then we could just call this point 9,3. So I'm just using mathematical notation, function notation, and then kind of what we already know. All right, so let's find the average rate of change from over a to b, which is the interval from 0 to 9. That's our a and our b. Okay, so finding the average rate of change of f of x from 0 to 9. So let's use our formula. So the average rate of change would be f of 9, since that's our b value, minus f of 0. 0 is the a value, so that's our y values being subtracted, divided by our b minus a. Now, normally we'd have a function we could actually plug these into, but this is a visual problem. So when our input is 9, our output is 3. So f of 9, right, is the y value when x is 9, and that y value is 3. Similarly, f of 0 is negative 7, all over 9 minus 0. So we'll have 10 ninths. Now, this really is just, and that can't be simplified, this really is just the slope between these 2 points. So from point to point, we rose 10 and horizontally ran 9. So yes, you could just do that if you have something visual. Really, the average rate of change is a way for us to sort of start to practice calculus and start to understand that a huge idea in calculus is really slope at one point, an instantaneous rate of change, as we bring average rates of change closer and closer together. But that is a calculus idea. So this is another idea using function notation to glorify slope and prepare us for calculus. Okay, in this next example, we do not have anything graphed, so it will have to be entirely algebraic. We want to find the average rate of change for this quadratic function over the interval from -2 to 0. So let's get it set up. We will do f of, so this is our a and this is our b. So we'll do f of 0 minus f of -2 all over 0 minus -2. And if you note in the interval, I'm always going to go from left to right. So this a value needs to be less than the b value. Okay, now how do we find f of 0 and f of -2? We plug them right into the function. And so I will do that. F of 0 doesn't really require that much work. If we plugged in 0 to this function, both of these terms will go to 0. So f of 0 is just -1. That one's pretty easy. But when we are finding f of -2, we will have to show a little more work just because that one's a little more complicated. So we'll do 3, and then we square -2 plus -2, so I'll just write -2 minus 1. So this is f of -2. I have to actually do some more work there. In our denominator, we will have a positive 2. Okay, upon simplifying inside the parentheses, which I'll go back to yellow here, this will give us 4 times 3, so that's 12, and then this is minus 3. So that'll give us a 9 on the inside. Didn't need that big of parentheses. And so we'll have -1 minus 9, so -10 over 2. So our average rate of change is -5. Okay, in this last problem here, we want to find the average rate of change over the interval from x to a point slightly further to the right of x, which is x plus h. This is really preparing us for calculus. The idea is that h gets smaller and smaller, and so we're finding the average rate of change from 2 points extremely close to each other so that it actually becomes 1 point, and that's called the instantaneous rate of change, or a derivative in calculus. So let's get this set up. We'll do f of x plus h, because this is our a and that's our b, minus f of x all over x plus h and then minus x. So again, we have f of b minus f of a over b minus a. Now f of x plus h is something that we've done already, so I don't need to go super in depth with what that looks like, but we will plug in x plus h everywhere there's an x, and we know how to square x plus h at this point. I'm not going to put this x plus h in parentheses since it's not being multiplied by anything. Minus 1, and then I'm subtracting f of x, so I need that in a parentheses because when we subtract we do have to distribute that negative sign. And then if you look in the denominator, the x's end up canceling out, so it's actually just over h. So I'll continue over here. When we square the x plus h, remember we have x squared plus 2xh plus h squared plus an x plus an h minus 1. Then distributing the negative sign looks like this. It's a lot all over h. We're going to distribute the 3. And then a lot of stuff is going to end up canceling out. So let's see what cancels out. Our 3x squareds are opposite, so they cancel. We have a plus x and a minus x, a negative 1 and a plus 1, and it looks like that's it. So what we have left is 6xh plus 3h squared plus h all over h. Then we can factor out the h to get stuff to cancel. So we'll factor our h out in our numerator. So our final answer, which I will write over here, is what's left. So it is 6x plus 3h plus 1. So the moral of the story is, kids, that the average rate of change, while it can look like a fancy schmancy formula, it is really just slope.